Hello everybody, in this video we'll talk about the Kappa aircraft Saphir for well test analysis and interpretation. We'll start with the interface of the program. We have the title bar and the menu bar. The menu bar contains file contains new for creating a new project, and open for open an existing project, print setup for selecting the format of my printout, and recent file list of the recent open files, and exit. The action menu contains the forward and backward, undo and redo, and the setting of the program, which we'll see in the wizard bar. We have the view menu and the help menu, which contains the program tutorials. The wizard bar will start with the setting of the program, the application. We can determine whether the program will auto-save my data or not. Then I can select the language. Here we have selected English, but we can change the language to any other language. The modules, we can select whether the program will work alone or work with other Ecrin environment programs like Topaz and Diamond. This is the application. The interface contains anything related to the shape of the interface, like the wallpapers, the background color, and any other colors of the menus, of the bars, and any other colors. The plot aspects, anything related to the plots, like the plot colors, the gauges colors, and the shape of the lines. Also the float phases, the model sensitivity colors, and the shape of the lines. The BVT contains the categories of our fluids, like gas, oil, and water. uh, each category of these contain the default correlations that the program will use to calculate your BVT parameters, and the default values, which we can change it. The interpretation will give you the default values that the program will make interpretation upon it, like the thickness, the permeability and flow capacity, the porosity, distance, heterogeneities, well pore radius, skin, and any other properties. The last thing I want to show it to you is a print setup, which you can select the format of your printout. We'll go to a new project by selecting file menu, new, or from the toolbar select new. In the first screen we have the test type. We have standard test and interference test. Our model is a standard test, so he'll ask me about the well pore radius and the base zone thickness and the porosity. Be aware and take care of your units in your model. Then the reference time is the time that the test has started. The default time will be today, but we can change it according to our model. The fluid type, we have different fluids like oil, gas, and water. Our model is oil, and we'll start with analysis. We have three types of analysis: standard, nonlinear, and multi-layer. Standard analysis is a normal way of analysis by using spatial plots and then the type curve matching. The nonlinear analysis is the way that uses the type curve matching for analysis, and the multi-layer is used when you have two or more layers producing. I click next. He'll refers me to the BVT parameters like formation volume factor, viscosity, and compressibility. I can calculate these values by checking off it and press calculate. He'll ask me about the reservoir temperature, pressure, and gas oil ratio, and any other properties, and when I press OK, he'll calculate the BVT parameters and also give me the graphs of the parameters, as we'll see at the end. I'll press create. Now I have a new project to work on. The next step is loading the data, the flow rate and the pressure data. We'll start by the flow rate. Flow rate is loaded in the extension of ASCII file. I'll press here to load the rate data, then click next. In the data format we have lines format, free, field, and column. The free is used when your columns are organized and have the right type and units. But if my columns don't have the right type and units, I can select field and change the type of the columns. If my file is not organized in columns, I can press column and specify each column for a property, like specify this column for decimal time and specify this column for IR rate. Okay, I'll select free because I have an organized file. The time format is divided into 4 options. Points, when your data is in the format of points or dates, specific dates in your history. And you can use steps, durations, when your data is like durations. Steps, time at start, when you want to relate your durations to the start time. Time at end, when you want to relate your durations to the end time. Here I'll relate my durations to the end time, and the reference time is the default. Then I click load. Now he loaded the flow rate data. As I made for the flow rate data, I'll make for the pressure data. ASCII file, I'll select the pressure data. Next, I'll select free, time, steps, time at end, and the reference time is the same reference time for the flow rate data. I click load. Now he loaded the pressure data. As we can see, when the flow rate decreases, the pressure data increases, so it's a build-up test. The next step is to extract the derivative plot to begin the analysis. Extract the derivative plot. You'll ask me about the number of the gauge. Here we have only one gauge, and you ask me to select the group of points. Here also we have an only one group of points of this actual data. Press OK. He'll ask me about the type of smoothing and the type of filtration points per cycle and the pressure. Okay, I'll take it by default and press OK. He has extracted the derivative plot, and the red points is the derivative plot and the green points is a log plot, and also he has extracted the semi-log plot and give me the history plot. Next step should be the model, but before the model we can make a small analysis of my extracted data. From the log plot I can get spatial line of slope equals 1 and create and give this line and match it with the log plot. Start of the log plot, I can find that it matches. That means that I have a well pore storage at the start of the well test. Then I can determine that I have the infinite acting radial flow. How could I know that? From the semi-log plot, when I get a line, this is a derivative plot, okay? When I have a straight line here, I can term that I have an infinite acting radial flow. So when you ask me what the type of flow regimes you have, I can tell him that I have a well pore storage and then infinite acting radial flow. The model step will ask me 4 questions. He'll ask me what's the well pore model. We have constant well pore storage, no well pore storage, and changing well pore storage. We have seen that the log plot have a straight line, so we have a constant well pore storage. The next question is your well model. You have various types of well models. We have vertical well, we have fracture, uniform flux, infinite conductivity fracture, finite conductivity fracture, horizontal well, and limited entry vertical well. In my model I have a vertical well model. And he'll ask me about the reservoir model. We have a lot of reservoir models, like homogeneous, when there is no heterogeneity in the reservoir, but if you have heterogeneity, it may be two porosity or dual porosity pseudo semi-steady state, or BSS. It may be two porosity slab, two porosity sphere, two layers, radial or linear composite. My model then tell me that he have any heterogeneity, so I select homogeneous. The boundary model may be infinite or maybe related to a fault, one fault, leaky fault, circle, parallel faults, intersecting faults, triangle, and rectangle. I'll select infinite and tell him to generate a model. As we can see here that the white curve of the model doesn't match the red curve of the derivative plot, so I should improve the model by selecting improve and then check off the option of white search to increase the accuracy of the improvement. Then I click run. He'll make a matching and give me the nearest match, and also I can make one more or two more improves or any number of improves to get the best match. Now I want you to see your output data. You have a vertical well, you have a homogeneous reservoir, you have an infinite boundary, you have the initial pressure of that value and the flow capacity, and a skin of 10.6 and compressibility of that value. As we can see also, he have drawn the history plot of the data. The last thing I want you to see is the sensitivity analysis. Analysis make me ask the program to give me the type curves that he searched in to give the best match. I can require the sensitivity analysis or the type curves of the skin. My skin is 10.6. I can require the skin of 8, 9, 10, 11, 12, 13, and so on. And when I click generate, he'll give me the curves that he searched in, all the type curves of that value, and the white curve represents the best match or the model. Also, I can make a new plot, for example a Horner plot. When I press OK, he'll give me the Horner plot. In the Horner plot, I can make a straight line, can draw a straight line to show if I have infinite acting radial flow or not. The straight line matches the Horner plot, so I have in this region I have infinite acting radial flow. The output of the program is the report. When I press view report, you give me the results and the output. I can pick the results or insert it in the report one by one by clicking like that, and I can insert all the results in the output, and when I click preview, he'll give me a report of all the data. Here is the gas data, the beta G, and then the gas viscosity and the gas compressibility. Then we'll go to the oil formation volume factor versus pressure, and the compressibility, the gas viscosity, the oil viscosity, bubble point pressure, and all the BVD parameters of the oil. Then the history plot, then the Horner plot, the log plot and derivative plot with the model, and the semi-log plot and sensitivity analysis. And I click print. I can enjoy my report. I hope that video will be useful for you to use this fantastic program. Good luck, my friends.